Repellent, I'm academic director of the Quest Launch Program, and it's my privilege to make a couple of announcements. The first announcement I would like to make is about the Project Poster of the Year. The Project Poster of the Year for this semester is by the Dallas men who worked with Dallas Defense. Their beautiful poster is easily identified by its green color and the blue ribbon on it over in that corner there. Check it out already. The next announcement is related to the Project of the Year. And before I introduce the team, I'd like to briefly describe the process by which they were selected. The senior Quest consulting projects all involve quality management, process improvement, and design of innovative systems. And all the student teams deliver value for their clients. So the alumni panel had a difficult decision to make last night as they watched all 13 of the presentations and met to make their selection. The alumni panel, which consisted of 7 Quest alumni, considered the methodology that the students used, the way that they analyze data in order to generate evidence to support their recommendations. They consider how the teams defined and justified feasible, desirable, and innovative recommendations that deliver value to their client. And of course, they consider the quality of their presentation. So it's my privilege tonight to announce that the project of the year is Artemis Solutions, who work with Tulkoff Food Products and T.W. Garner.
Okay, great. They were hearing okay? Can I do like this? Like this? Great. So good evening, everyone. My name is Issa. This is Kenny, Yoni, Mark, and Grace, and we are Artemis Solutions. Now, unlike a lot of the projects you guys heard from tonight, we actually have 2 clients on our project. The first was Tulkoff Foods, based in Baltimore, Maryland, and better known for their horseradish production. The second was T.W. Garner, and they're based in Winston-Salem, North Carolina, and they're best known for the production of Texas Pete hot sauce, which some of you may know. Now, both of our clients, when they're making these great products, are left with waste products, and their hope is to repurpose this waste product into something that is beneficial to their company. Now, Tulkoff's waste product comes from the actual horseradish root itself. When they're preparing the root and getting it ready to make the sauce, it gets washed and part of the skin of the horseradish root itself gets chopped off, and that's what they're left with. T.W. Garner is from the pepper from their hot sauce. After they use the pepper, the inside of it is what's left as waste, and they're left with that. Now, both of our clients believe that their waste product can be used as deer repellent. The reason being, there's an active ingredient in the horseradish root, and then a different active ingredient in the pepper that have been proven before to repel deer. Now, Tulkoff produces 100 tons of waste each year and spends $6,000 to get rid of it. T.W. Garner produces 400 tons of waste each year and spends $30,000 to get rid of it. So what happens if we show that it does in fact repel deer and they have all this waste product to work with? What does that deer repellent market actually look like? Well, in 2008, it was found that there was $5 billion in deer damage in suburban America. In the state of Maryland alone, there's $10 million in crop damage each year due to wildlife, and 77% of that damage is due to deer. And we spend $410,000 on preventative measures, but clearly that's not enough. So the purpose of our project is to test the feasibility of turning our clients' waste product and turning it into deer repellent.
So the first step of our process was to talk to a potential customer. So we visited Ben Alda, owner of Homestead Farms in Poolsville, Maryland, and he confirmed that deer were actually a huge problem for him, resulting in significant crop damage and also profit loss. He reported spending over $100,000 to control deer damage. Now, once we verified the market need for this product, we wanted to go ahead and test it. So we consulted with Dr. Bruce Kimball, a deer repellent expert at the U.S. Department of Agriculture. And he advised us in creating a plan that was both efficient and feasible for the resources available to us. Now, how did we actually go about testing this? Well, we wanted to test our byproduct repellents in their most effective form. And to achieve this, we worked with Dr. Frederick Katchik, an organic chemistry professor here at the University of Maryland. He helped us develop a cost-effective method to isolate and extract the active ingredients that we found to be present in our byproduct. So what are these active ingredients? Well, the first is allyl-isothiocyane, and this is found in horseradish, and it's responsible for that sharp taste that you might be familiar with. The second is capsaicin, which is found in pepper, and it's responsible for that spiciness. Now, these two active ingredients are actually well-known mucosal irritants, which makes sense for them to be possible deer repellents. To actually extract these active ingredients, we went through a chemical extraction process, where we performed 2 extractions, one for each byproduct. And the first thing we did was homogenize the byproduct with an extraction solvent. The second thing we did was we filtered out that solution, and then finally we evaporated out the solvent, which left us with our isolated, concentrated active ingredient, which is the repellent that we used in our field testing.
So after we had isolated our active ingredients, we wanted to take what we had gathered in the lab and test it out in the field. So we found a location in Baltimore, Maryland, and saw a frequent number of deer visits throughout the day. Now, throughout the semester, we spent approximately 150 person-hours conducting the tests and collecting the data. So this image shows you a bird's eye view of our test setup. From here, you can see that we separated each test site by 10 feet. This ensured that the deer had an equal chance of going to any site. At all the sites, we placed down a pile of corn feed to attract the deer. At site 1, we had just the corn feed. At site 2, we added a commercial repellent, which is available at stores today. At site 3, we took our horseradish byproduct active ingredient and actually mixed it into the corn feed. And at site 4, we took our pepper byproduct active ingredient and mixed that into the corn feed. So our metrics for success with this setup was how much feed was actually eaten at the end of the day. So to help us along with that, we installed 4 cameras throughout the site. These cameras gave us an individual view of each site so that we could actually visually see how much feed was being eaten throughout the day. But in addition to that, they also gave us the ability to look at the deer's behavioral patterns. So how many unique deer were visiting each site, and how long those unique deer were staying. So to give you a better sense of what we've been seeing the entire semester, we'd love to show you one of our favorite clips. So here we have a baby deer approaching one of our sites. This is site number 3 with the horseradish byproduct active ingredient mixed into the corn feed. So we've circled the site for you so you can accurately see the pile. So what's happening here is that the baby deer is actually going to the pile. He's sniffing around, she's sniffing around for a little bit, maybe taking a lick or two, and then walking away. So what this video doesn't show is that this deer next goes to site 4, which is our pepper byproduct active ingredient mixed in, stays there for an even less amount of time, and then moves on. These results show enormous potential for our clients' products, and we're really excited about it.
So these videos are actually representative of the way that the deer interacted with the 3 test sites at SM Repellent. They would visit, scope out the site for a few seconds, and then decide they didn't like it and leave either immediately or up to about 30 seconds later. However, when the deer visited the site that had no repellent use in, they behaved very differently. After scoping out the site, they would typically decide that they liked it and stay and eat at the corn feed for up to about 4 minutes at a time. So we compiled all of this video evidence that we collected, and we looked at some of these features that Kenny spoke about, such as the number of visits to each test site and the amount of time that the deer spent at each test site. And we compiled this chart, which we think best represents the results of our testing. So there are 2 things that I'd like to direct you to this chart, which represents the average time spent at each of the 4 sites over 1 test period. So the first thing that I'd like to direct you to is the comparison between the site with no repellent, which was our negative control, and the 2 byproducts. And if you notice, there's a huge difference in the amount of time that the deer visited with the site with no repellent compared to the way they interacted with the site with the byproducts. And it's actually a statistically significant difference. The second thing I'd like to direct you to is a comparison between the two byproducts and the commercial repellent. And as you'll notice, there's almost no difference between the amount of time that the deer spent at these two sites, indicating that our byproducts are comparably effective as repellents as what's currently on the market right now. The other type of evidence that Kenny spoke about, which was a visual inspection of the sites at the end of each test period, further supported this statement. What we found was that the site with no repellent at all was completely empty of deer feed at the end of the test period. The deer loved it and they ate all of it. But the 3 sites that had repellent were hardly touched by the deer. It was indistinguishable, the amount of deer feed at the start of the testing and at the end of the testing. So what does this all mean? Well, effectively it means that our goal from the start of the semester to look into the feasibility of these byproducts of deer repellents was proven to be effective. And we're very, very excited to recommend that our clients move forward with pursuing commercialization of these byproducts. So, to summarize our reasons for this, the first feature of interest, as Issa mentioned at the beginning, is that there is an unmet need in the deer market. $5 billion in damage in residential area alone has been attributed to deer, and that number is rising as deer populations continue to grow. The second feature is that our clients have access to this byproduct, which they're currently spending money to get rid of. So they have a lower cost to enter the market, which will help them against their competitors. And finally, our semester-long deer test setup confirmed that these byproducts were comparably effective to some of the top commercial repellents on the market right now. So we really recommend that both of our clients continue pursuing these as deer repellents.
So after making this positive recommendation, we wanted to lay out a few next steps for our clients. Our first step is to conduct another round of testing to obtain EPA approval. Although these products are 100% organic, they still require EPA approval in order to be on the shelves in the store. Going on from there, we're suggesting a type of optimization testing. This will help our clients figure out the precise concentration and mode of delivery, whether it be a spray or a pellet, that they will actually sell. From there, we wanted to go ahead and make a potential impact estimate. What would our clients see from this? Making the assumption that they take all of their waste and turn it into deer repellent, and that they're selling this deer repellent for $50 per gallon based on the square footage coverage, they're looking at a $3 to $5 million revenue each and every year. To break that down a little bit more, we talked to experts in the field of industrial extractions to see what kind of cost they were looking at for this process. After collecting all this information, we were able to make an estimate that our clients receive a 40% profit on each unit. This means that they're turning their original $36,000 cost into a $1.2 to $2 million profit each year. These numbers are great, but they're really just the icing on the cake. We want to reiterate that we were successful proving that these byproducts function as deer repellents. This process was exhilarating, but very challenging, and we had a lot of help throughout the semester. I would like to start off by thanking our project champions, our faculty advisor, all the subject matter experts that took time to help us, to the test site, and all the people who allowed us to use our test facility in Baltimore, Maryland, and the entire Quest community. Are there any questions?
Did you consider combining the two ingredients to see whether they might be more effective as deer repellent?
So the question was, did we work on combining the byproducts to see if it was a more, a more functional repellent? That was not something that we looked at in the scope of this project. What we were really focusing on was, would these byproducts work as individual deer repellents? This is something that we would suggest might be part of the optimization testing, maybe by combining the two different repellents that we worked on. They had some sort of hybrid, extra strength combination. But as far as our project, we really focused on just proving that our individual byproducts would work as deer repellent.
How expensive is it to place select the active ingredient for the waste product, and how difficult is the process?
So when we scale up the process. We talked to a lot of industrial people who actually do this process, and based on their estimates, to buy a single extractor costs around $250,000, but that's just a flat fee of the extractor itself. Now, additional costs would just be the utilities that are involved in running that extractor.
Did you try just mixing the raw product that was produced at the factory with the food rather than thinking about extraction?
So the question was, did you try to just use a raw product? And yes we did, and it failed miserably. It was a huge frustration for us initially, and that's why we didn't talk about our initial testing. We had 2 weeks of this raw byproduct testing, and it was just, again, very frustrating. So then we sort of took a step back, and that's when we contacted Dr. Kachik, and we worked on isolating the active ingredient, and that worked beautifully for us, so we're very happy about that.
Do you know what the active ingredient is for the current beer repellent on the market?
So the question is, what is the current active repellent for the deer the active ingredient for the deer repellent? And the one that we use actually uses an egg-based product, but there's a lot of different deer repellents currently on the market. In fact, they range from slaughterhouse blood to other chemically produced products. So that's another strength of our product, that it's all natural. So that's also a selling point when we eventually produce this repellent.
Would the deer repellent work only if the deer went like taste something that added on it, or just by smell too?
So that's actually a reason that we think that, sorry about that. The question was, do the deer repellents work based on taste or based on, thank you, Mark. So there are actually different deer repellents on the market work by those 2 different ways. Some of them work by taste and some by smell. And actually the horseradish and the pepper, there's indication that they work by those 2 different methodologies, which ties back into that first question about them potentially working better as a mixture. So there are a variety of different ways that these work, but both of these did work at the common deer, which is where it goes.
One last question.
Oh. One last question.
Does your byproduct have any other uses outside of beer repellent?
So the question was, does our byproduct have any other uses outside of deer repellent? So these active ingredients have been used for other things in the past. However, external uses were outside of the scope of our project. What we were really focusing on was proving that they would work as deer repellents, which we were very happy to be successful with. These active ingredients could be used in other situations, but it's something that we chose not to focus on since it was successful.